Yo, Matt's first on the stream. Where's my camera? It's not up there anymore, it's now up there. Evening, buddy. Hello to Jesse. How's it going, Matt? Not heard from you in a little while. Hope you've been alright. Have you been surviving the heat okay over here? So, today we're going to be continuing with Gian's STEG 5K that we were having some problems with last time. If you weren't with me on the last stream, we were looking at why this thing produces beautiful drive and output waves, and it appears to work perfectly fine until you drive a load, and when you drive a load it loses the top half of the sine wave and the high side FETs heat up like crazy. Like crazy. Yeah, it's been crazy hot, and it cooled down a bit, but I get the impression that the heat is picking back up again. Yeah. Hi man, RF Team Turkey. Is that Rockford Fosgate team? To Khan. Good evening. So Gian asked me a question, but he's not on live chat. He said, what do you think about master slaving? Is it any good, or would you rather wire them up differently? I would personally rather wire them up differently. I'm not a huge fan of slave master, but I can check, because I'm going to be repairing a couple of amplifiers for him, a couple of B2 monos, and I'm not a huge fan of slave master because I don't trust the amplifiers to be matched well enough from the factory to not cause issues in slave master. I would much rather match them up perfectly myself with a scope or with any of the other tricks that I have mentioned on my other videos, as opposed to slave mastering. Not a massive fan. Alright, here we go. Giant's now on the live stream. Wicked, wicked. Let's wait for the stream to pick up a little bit. 16 watching already. Pretty good. Alright, so. Good afternoon. Good afternoon to Vicente. Vicente? So. I had a couple of ideas with this. So we looked at the STEG last time, and one of the things that I thought might be the issue, we were having a look at the driver board, and I've actually pulled the driver board off now, so I'm going to show you the driver board up nice and close. This is the driver board up nice and close on the STEG. It has a HEF 4060 chip, which is up here. Now this is doing all the Class D generation stuff. This is the stuff that's turning the audio into the pulses for Class D operation. You have a couple of small audio amplifiers here and here, and then you've got, I can't remember what, I think these are high and low buffers or something. I can't exactly remember what these do, but yeah, essentially you've got the Class D generation up here, and you've got the output over here. You can see there the pins are labeled HGL for high output, ground, low output. SD is shut down. I haven't figured out quite what 1 and 2 are. They have different things on them. One has a square wave on it, 2 has, oh no, sorry, 1 has an audio wave on it, 2 has nothing. I think that could be channels. Obviously this is a mono amplifier, so it's only one channel, but this is a driver board that maybe was designed to be used in a variety of different amplifiers. In the last live stream, I was thinking that maybe the 2 audio amplifiers here were had some faults, because I was tracing back the glitching issue, and it appeared to be coming from these audio amplifiers. But I changed those chips today, and the issue hasn't gone away. Nothing has changed about this. It's doing the exact same bullshit that it was doing before. So I was looking at the rest of the circuit, and I was testing absolutely everything, and I honestly, for the life of me, there doesn't appear to be anything on here that would cause that to happen, apart from perhaps because this was worked on by a previous technician who fitted all these parts, and he did a good job, by the way. The soldering looked really nice, but he fitted some really high power MOSFETs on the output section. He fitted some where did I, they're in here. I'll tell you what FETs he fitted. He fitted some IRFB 4228s, which are, I think they're 85 amp FETs from memory, and they're about 380 amp pulse drains. So they're very powerful FETs, and they need to be driven strongly And I wonder whether this circuit originally had something much weaker in it, and the other technician decided, what the hell, let's put some really high power FETs in this, and should be right. But I've got a feeling that these FETs aren't original, and I've got a feeling that this drive circuit can't drive them properly. In my head, I'm thinking, right, when the amplifier is put under a load, what's happening? So the MOSFETs they're the things that are taking the rail voltage and they're turning it into a sine wave to put onto the speaker terminals. So if the issue only presents itself when the amplifier is put under a load, then that, to me, signifies that the issue is when the MOSFETs are asking for current. So the rail voltage doesn't differ. That it's not an issue with the rail voltage generation. That's fine. The rail voltage doesn't dip. It's the drive that disappears. The drive circuit gets knocked out. So I'm wondering whether the drive circuit isn't driving the FETs well enough, and when the FETs demand current, they actually put extra strain on the drive circuit, which is a thing. That does happen. When the FET is doing a load, it does ask for a bit higher gate charge than it would be at idle. So I'm wondering whether the drive just can't keep up with the demand from these FETs when they are put under a load. So what my test is now is I'm going to put some super easy to drive FETs in this board, just temporarily. I'm going to put it back to the heatsink, and I'm going to try driving a load with some IRF 640Ns, which are incredibly easy FETs to drive. Now this is called a STEG 5K. 5K is the peak rating. This will, I expect, will probably do somewhere around 2.5K at 1 ohms. So looking at we've got 5 MOSFET locations on each side. If we go by other generic amplifiers from China, for example, the base phase DB1.3, that thing does about just under 2K. Yeah, actually it does just over 2K. I think the V3 does about 2000 watts RMS, and also I think that thing has 5 FETs on each side as well, and the base phase uses 640Ns from the factory. This thing might have even used 640Ns from the factory, but I have no idea because it came with 4228s in it, or 4428s or whatever. So what we're going to do, I think the 640Ns will be fine in here, just for a quick test at least, and it should show up to me whether the issue with this amplifier is that it's got FETs in it that are too goddamn powerful. And we'll go from there. Oh, and one other thing that I was going to check as well, just quickly while I remember, I wonder whether this thing actually needs 200 volt FETs. So, first thing we're going to do is we're going to check the rail voltage, because the IRFBs that were in here before, which, I've lost those again. The IRFBs that were in here before, IRFB 4228, these are 150 volt parts. And this is an amplifier that should be doing about 2.5K, and I wonder whether this really needs 200 volt FETs, and I wonder whether the other technician thought, nah, it'll be alright with the 150s, whereas actually that is what could also be causing the problem as well. It could also be an issue that the FETs aren't happy because the rail voltage is too close to their breakdown voltage. So, two things we're going to try. We're going to first of all test the rail voltage and see whether it's too close to the breakdown threshold for 150 volt FET. If it is, then we'll go for 200 volt parts. If it's not, I'll put 640Ns in. I hope everyone followed that. That was quite a lot of information there. I hope everyone... So is everyone following what I'm doing? Does everyone understand my thought process here with this? If not, let me know and I'll try and explain any part of what I'm doing in a bit more detail. The guy I bought it from told me the previous repairer repaired multiple STEGs with the same FETs. Ah, okay. Oh, that's annoying. So it could mean that this is a waste of time then, but I want to try it anyway. Okay, so let's fire this thing up, and first of all, I'm going to check the rail voltages. Oh, that's something on the floor that my hat cam is looking at, and I think that's a packet of crisps. Yeah, anyway, yeah, so let's go for checking the rail voltage and see what that is doing, and see whether. Oh, this is good. So let's go ahead and power up. Oh, we need the remote cable plugged in. Okay, so rail voltage, how high are we? I'm going to remove the driver card for this actually, just be on the safe side. Doesn't need the driver card in there, just to test the rail voltage. Okay, so with 10 volts worth of input, so you can see here we're drawing 1.7 amps. With 10.3 volts worth of input voltage, we are up at 76 volts. Holy shit. What the fuck? If we... No way. This can't be using 150 volt parts. This needs 200 volt parts. Absolutely. We're already at 10 volts above the threshold for the 150 volt parts. They were running hot on idle as well. Let's go for so 14 point... When this stabilizes. Come on, stabilize, you did. Right, so at 14.5, 14.6 volts, how high is the rail voltage? It's regulated, so it's the same. It's still 76 volts. That's a pretty cool power supply. So as you can see here, if we zoom in on the power supply wave... why isn't this... Oh, I need to source it on number 1. Yeah, so if we look at the power supply wave, you might think that oh dear, there's a problem there. But actually, no, this is intentional. So with 14.5 volts worth of input to the amplifier, we have the same rail voltage as we did with 10 volts worth of input voltage. So it is like a JL audio in the sense that the rail voltage is regulated. So that means that if you do run this at a lower voltage on the car battery, it will still do the same amount of power than it would do at 14.5. It will just demand a bit more current. So yeah, if we go back down to but that's 76 volts RMS, and that already puts us over the breakdown threshold for the IRFB 4228. So therefore, this needs some 200 volt parts in it for sure. So if we go back down to 10.3 volts, let's have a look. Yeah, we're at 76 volts now. Yeah, so it's pretty much the same rail voltage, and but the current draw is actually higher. So when we were up at 14 volts, we were only drawing 0.8 amps, whereas now we're drawing 1.4. So you can see there the correlation between low voltage equals higher current, higher voltage equals lower current. I can't get everything in this bloody camera view. There we go, it's a bit better. Right, cool, okay, so in that case then, I'm not going to put 640 ends in the board because they are also 150 volt parts. I'm going to stick some 200 volt parts in this, and I have some IRFB 38N20s, which should be more than enough to see what this thing is doing, and actually should be more than enough to cover this amplifier to full power anyway. The 38N20s are pretty good FETs. So yeah, let's see what we've got going on in the live chat. Your audio is crackling. I'll tell you what, my audio could be clipping because I think I might have the gain turned up a little high. So maybe I should go ahead and turn the gain down a little bit on here. Let's go filters, gain. So if I talk pretty loudly, it's going. Mic check, 1, 2. Okay, that should be a bit better because I tend to talk quite loudly. I know I don't need to talk loudly because the microphone's very close to my face, but do another boozy amp repair. It was so fun. Yeah, I definitely will do another boozy amp repair at some point. But I need you see, the boozy amp repair only works when it's my own amplifier, because I think it's a bit irresponsible to start to work on a customer's amplifier when I'm highly intoxicated. It's not very professional. So if I get another amplifier in that's my own, that I think we could do a boozy repair on, then I'll by all means I'll do that. That'll be good fun. Alright, so let's wait for the rail voltage to sink down then. We're at 29 volts on the rail still. So let's take our dummy loads here just to quickly discharge. The rail caps so I can get on with this repair quicker. VCC plus, VCC minus. There we go, that should have grounded now. That should be down at 0 volts. Yep, we're down at 0 volts. Okay, cool. So now I'm ready to put some FETs in. So 38 N20s. Watching from the Trinidad and Tobago. Awesome, fantastic. I'm actually doing a wedding for a guy from Trinidad this weekend. And he wants some soccer music. So if you're from Trinidad, can you tell me anything about soccer music? Can you give me some recommendations on what sort of thing I should be playing? I heard STEG amplifiers are the best value. I can't really answer that because we don't get STEG over here in the UK. So I'm not really familiar with their pricing. It seems like a fairly decent amplifier. I wouldn't say it's the best that I've seen in terms of, but no, it seems like okay. Get all these FETs the correct height, because if this works I might go ahead and leave these in. But to be honest, from what Gian is saying just now, the fact that these have been repaired with these FETs before and they seem to work fine, then maybe I have other issues and this isn't actually going to help things. But with a rail voltage of 75 volts, 76 volts plus minus, I do feel much happier having the 200 volt parts in here anyway. So even if this doesn't cure the issue, I will be happier knowing that there are some FETs that have a bit of voltage headroom in them. It's never a good idea to run the FETs on their voltage limit at all, because the tiniest spike in the drive, if there is a spike in the rail voltage or anything for whatever reason, then yeah, it can just kill the output section in no time at all. Do you think the Alpine PDX V9 a reliable amplifier? Yeah, Alpine, pretty much all the stuff I've seen from Alpine has been fantastic. Very, very good, clever circuit designs, modern stuff, built well as well, a decent build quality. So yeah, it should be pretty reliable. I can't picture that exact model just at this point in time, but yeah, I think generally Alpine stuff's pretty solid. Shouldn't have any problems with that. Crackling is continuous, but the issue might be my throne. Okay. I recommend taking it back to the throne shop. Well, isn't throne another word for toilet? Thanks again for fixing my amp. I'm the Facebook PM lad with the reverse polarity protection diodes. Oh yes, that's pretty cool. No problem at all. So I had a guy here on the live chat, Cathedrix. Yeah, he was messaging me. Thought he fucked his amplifier, connected it reverse polarity, and it was had a direct short across the power terminals. So obviously, that would indicate that the amp's fucked, blown the power supply. But he sent me a picture of the board, and I noticed that it had reverse polarity protection diodes, which sacrifice themselves if you accidentally connect in reverse polarity and they short out, which is what was happening. So I just said to him, cut the diodes out and see if it works in correct polarity, and lo and behold, it did. So it saved him quite a expensive repair bill from his country, having to ship it overseas to get looked at. So I'm just putting these 38 N20s in the board. I've taken the IRFB 4228 off. They're 150 volt parts, and this amplifier needs something at least 200 volt FETs on the output section, because obviously you've got the positive voltage rail and the negative voltage rail. So if you see 75 volts on the positive rail, then you'll also have negative 75 volts on the negative rail, and therefore the potential difference between the two rails will be 150 volts, 2 times what you see. Whereabouts in the UK are you? I'm down in a place called Dartford, which is in Kent. It's just southeast London way, down south, south of the River Thames. Okay, cool. I'm just going to do a touch more soldering on the top of the board here. A couple of these pads look like they have some strong connections to the top, the copper on the top of the board. I'm just going to make sure that these are connected nice and solid. Yep, looking good. Just want to connect that source one a little bit better there. Alright, cool. I'm travelling to the UK and France either March or April next year. That's pretty cool from Australia. Yeah, that's a long way, big trip. Do you still have your DDZs? I have some new ones that are being built at the moment in Oklahoma. DD. So I'll actually, when I go to visit Oklahoma in a couple of weeks, I'll actually probably get to see them being built, because I think they just happen to be being built at the time that I visit. So I should be able to get some footage of my new DDZ4s actually being built, which is pretty cool. Right, so let's put this back, slide this back into the heatsink. The reason for that is because we are actually going to be clamping a bit of a load on this, and it's never, you should never really clamp any power on an amplifier with the FETs out of the board here. They need to be clamped to the heatsink. Looks like the repair guy used some unnecessary thermal pads as well, in addition to what's already on the board, on the case. This amplifier has some pretty big, some permanent fixture thermal pads, and he added some extras in addition to, so just created an even higher resistance path for the heat to transfer to the case. So we're going to remove those. I'm also just going to remove my wires from the board while I slide this in, so I don't take everything off the desk with me. For those soccer songs, not all are wedding material, but it would should give you a feel of rhythm. Check Private Ryan's 2018 soccer list. Thank you, I'll check it out. Back in the case she goes. Easy does it. Don't want to do it too quickly and take any FETs off or knock anything out off the board. This is nice and tight into the case, this one. There we go. So yeah, just in the case now, and I'm going to put the MOSFET clamps back onto the FETs, just here, so onto the heatsink. I should probably add a bit of thermal paste. I don't really want to yet because I don't know if these FETs are going to be staying on here, but okay, let's add some thermal paste. Back to my crisp packet there. Okay, thermal paste, HY88, sorry, HY810 this one, but the HY880 is the one that I recommend. Okay, now I've got to find my hammer to put these back on. I couldn't find it earlier, probably on the floor somewhere. Yeah, I'm just going to go and grab myself a hammer because I can't find the one I usually use. So I'll be back in just a sec, and then we'll have these clamps on and see if this works. There we go, here's my slightly bigger hammer than usual. There we are, there's one. Two. And I've also got to do the ones over here on the power supply. I've got to do all of these MOSFETs. When we're clamping power from the amplifier, all the FETs have got to be back on the heatsink, otherwise they could overheat and fail. Almost there, just the other side of the power supply to go. A bit confused, there should be one more of these clamps, possibly. Ah, no, I think that goes like that, okay. Yeah, screw it, it'll be fine for now. Be fine for this quick test. Let's put this one over here. Put one of these clamps over here. Right. MOSFET's clamped back on, so we can put some power and see if it likes these new FETs any better than the old ones. So the old ones, I think we were drawing 2.2 amps at idle with the FETs from the previous tech. So be interesting to see if this is any higher or lower with these 38N20s. What do we think? Do we think it's going to draw more current at idle or less current? And do you think the FETs are going to fix it? Do you think my inkling is actually correct? Or do you think we have more drive circuit problems to look at? David, is it worth to buy and repair older broken amps, or is it better just getting new Class D ones with 1,000,000 watts of power? It depends what's wrong with them, and depends if you can be bothered and have the time to fix them. Yeah, it's always worth fixing stuff, I think, for sure. And a lot of the time, old school amplifiers are actually a lot better, nicer sounding, etc. than newer stuff. So yeah, I think it's definitely worth repairing older amplifiers. The new Class D amplifiers, yes, they do a lot of power for little money, but often they have reliability issues, and they often don't sound that great either. Okay, cool. So let's go ahead and see if this resolves our issue at all. I'm going to turn the voltage up a tad actually to about 12 volts because it was actually preferring the slightly higher voltage with the regulated power supply here. So let's go ahead and we're going to probe the let's probe the low side drive. I might need to change the value of the gate resistors here slightly. They're they're 28 ohm gate resistors on here at the moment, which is a little on the lower side. Might need 47s or something, but let's have a look. Have you heard of Twisted Sounds? Yeah, Twisted Sounds, very good amplifiers. They're made in Korea, the same as my LW Audio stuff, and which is very reliable. So yeah, I'd recommend Twisted Sounds based on the LW boards. Just before we apply power, I'm just going to make sure that we haven't made any solder bridges anywhere. Always worth checking, double checking. No, I think we're good. Cool. Right, let's put some power. So up on the screen there, I'm going to be showing you the low side drive. Okay. It doesn't seem to be doing anything now. Oh! Ha! The driver board's not in. Stupid ass. Thought I'd broken something then. But Gian was like, no, what has he done? It's not working at all now. Yes, the driver board, I forgot to put that back in after I finished soldering the FET. So let's discharge the rails, because I don't want to put the driver board back in with the rails charged. It's just a good idea not to. There we go, rails discharged. What's your opinion on the B20 I sent you? Yeah, fantastic. B2 amplifiers are very, very good. Really, really nice stuff. I'm a massive fan of the B2 amplifiers. Good build quality, legit power most of the time. Right, so let's try that again. Have to pulse the amplifier on a few times. There we go. 2.5 amps, and we're drawing a bit more current this time, and the low side drive looks like this. Okay, cool. Looks like we got quite a big spike on that on the way up. Ooh, yeah, potentially quite a big spike on the way up there. So if I zoom into my scope, I'm just going to turn that off for a second. If I zoom into my scope here, you can see what I mean. So we might need to change the gate resistor value slightly of these ones just to get rid of that spike. So if that's causing an issue, which it might not be. So yeah, let this thing turn on. So you see at the start of the wave there's quite a big spike before the gate rises, so that might be an issue, and that can be solved probably with a higher value gate resistor by the looks of this. We could probably go with a 47 ohm or something like that. But the drive generally looks pretty good. On the high side drive, that looks alright as well. So now we have the task of seeing whether this, with these new FETs, exhibits the same problem as it did with the other FETs, in that when we load the amplifier, we have a really nasty looking top of the wave, and the thing draws excessive current. So let's go ahead and wire up my dummy loads here to the amplifier. Now, to get this to do this properly, before I needed to be running it on my Dell server power supplies in order to turn the gain up enough for the issue to exhibit itself. But hopefully this time, I think earlier I did it and I could sort of just about see the issue on the small regulated supply here. So I think we're going to put a 1.3 ohm load in the amplifier. I was trying a 2 ohm load earlier, but I think I'm going to go with a 1.3 just now, just to draw a little bit more current from those FETs, which is what the issue was causing before. It was when we drew current. So let's pop that in there like so. So we've got a 1.33 recurring ohm load. Sam, are you going to PD at the weekend? Good question. Is it on the Saturday or the Sunday? I might be, yes. I should be able to go to PD. I hope PD's not on the Friday, because if it's on the Friday I can't go. Right. Okay, so now we need signal. That'll be from a frequency generator on my mobile phone. We're going to play about 48 Hertz, just the first number that came onto my screen there. Okay, let's turn the scope to a different setting so I can read the audio output wave. Reject high frequency, turn that down. DC coupling. Turn that to about 10 volts, divide. Okay, this is the moment of truth then, guys. Has swapping the FETs out resolved the issue or nah? The Bud 666 Bud, we just swapped the FETs out for, this originally had RFB 4228s in it, which are 150 volt parts. The rail voltage was plus minus 75 volts, so it was right on the breakdown voltage of those FETs. So I swapped them out for some 200 volt parts that are easier to drive, and I'm wondering whether this has resolved the issue. So I'm going to zoom into my scope so you can see. Let's turn the amplifier on and see what we have. Those didn't have any audio at the moment, which is odd. Why don't we have any audio? This happened earlier as well, actually. I didn't have audio one time. The signal was too low. Okay, I need to turn my phone up. Signal is still very low. Why is the signal so low? Signal's very, very low. Why is that? That's better. I think the high pass was turned up quite high. So, all right, let's get this started then. Noise rejection off. Reject high frequency. Yeah, it doesn't do the issue that it was doing before. So now with a load of 1.33 a load of 1.33 ohms on the dummy loads, I'm not getting the same issue that we had before. The sine wave stays a clean sine wave all the way up to 14 amps, 15 amps, 16, 17, 18. It stays looking good. Right, okay, that has given me enough confidence to be happy to plug this into my Dell server power supplies and to do the same test. So this is positive. What I'm going to do, just one more test. I'm going to plug in the 1 ohm load. So I'm going to drop it, add on the fourth and final static load here to give us a 1 ohm load on the amplifier. I won't be able to turn this up very much. As you can see there, it's already starting to reach the 20 amp limits of my my regulated power supply there, but this should put a little bit extra load on the FETs. So let's see whether this also doesn't make a problem. Keep an eye on that current draw from the power supply. $14, $15, $16, $17. Sine wave still looks good. Okay, this is positive stuff. I still don't know if it's officially 100% sorted yet, because changing those FETs could have just made this issue present itself at a different output level. But we are going to now plug the Dell server supplies in, and we're gonna I'm gonna have to actually reassemble this amp properly to do that. So with all the screws in and everything, because we're going to be drawing a high amount of current from this thing. And we'll see if the sine wave still does the weird stuff or not. So yeah, just bear with me while I reassemble this properly. I have confidence in this, actually. I do have confidence in this. What are you thinking, Gian? What are you thinking, buddy? So for those of you who don't know, the owner of this amplifier is actually watching me live repair this on the stream. He's Gian Stevens in the stream, which is always interesting, having the customer watch you repair the thing live. Okay. Right, so first things first, I'm going to solder the driver board back in, because we desoldered the driver board from its mount. So let's get that back in properly. Then there was another thing I had to do. I need to reconnect this ground wire to the amplifier from the underside or something weird. I can probably pull it up the side. And we're going to take these MOSFET clamps off. I think I need to push the board in a little further, sticking out just a touch. Doesn't it make you nervous? Yes, massively. So this it doesn't usually make me nervous. Oh, sorry, having the owner watch me. No, not really. I'm confident enough that I know that that I'm not going to massively screw anything up big time. The worst thing that I can do is my finger can slip on the probe, but I can short something out. That's the worst that can happen, and that's not necessarily down to amplifier repair skill. That's just a shit thing that can happen. So yeah, it doesn't. I'm not too unsettled by the owner watching me repair it live. It's not too bad. Yeah, this little bit of wire is annoying. Whoever repaired this last put in this really annoying bit of wire here. Hello again, Sam, says Amir. Thoroughly enjoying these live streams. I noticed you don't upload all your live streams though. No, they are all uploaded, but I don't set them all to public because there's just too many. There's so many. If enough people want me to, I can set my live streams, all of them, to public, but my channel will just be absolutely flooded with old live streams that are like 8 hours long. And I thought that wouldn't be particularly interesting. If I get a really good live stream, I'll often edit the live stream and then upload it again with all the boring stuff like this cut out. What's up, Sam? Good to have you back. Thank you, buddy. It's good to be back. That case ground wire can go somewhere else. I don't like that it goes under there. Maybe you can transfer your old live streams to another channel. I don't know how to do that. I don't believe that I can transfer a video from one channel to another once it's already on there. But I don't think there's a way of doing that. If there was, then that would work. Yeah, for sure. That'd be alright. I live in the States. I have most of the tools necessary to do amp repairs, but was wondering, where do you buy most of your parts from? Do you mean like MOSFETs and stuff? Like amplifier parts to do repairs, or do you mean like oscilloscopes and stuff like that? I got all my stuff pretty much second hand off eBay. Oscilloscope was second hand off eBay. Really, really good bit of kit. bit confused. Where do these fan wires come up from? They come up the side or what? I'm a bit confused where these fan wires came from at the side. So these fan wires on here, they seem to get trapped by the end of the board, and I can't see any cutouts for them or anything. So I'm a bit confused exactly where they came up originally, because the board doesn't sit back again nicely against the thing anymore. MOSFETs, capacitors, etc. I see the problem is I get all my stuff from UK based shops, so me saying the names of these shops and stuff is probably not going to be too very useful. Okay, I guess that works. Mouser isn't any good if I'm from the UK. Mouser, I have to pay horrific markup. Well, sorry, I have to pay horrific on shipping from Mouser from the UK, which isn't any good. Best place in the UK is either RS Components if you need things in a hurry, or if you don't want to wait. Sorry, if you don't mind waiting. And especially if you've got a company, then you can order from a place called Mercatio, which is very cheap, getting stuff in bulk. You do pay postage, so it's a good idea to get things all in one go from there, big orders, big parts. But it's much cheaper. Mercatio. Sometimes they're more expensive than the RS, but most of the time they're much cheaper. Alright, so just got to put those clamps back on. Then we can do a proper bench test with the Dell server power supplies, and hopefully the issue has gone away. If it's not, then taking this apart was probably a waste of time. What did you pay for your O-scope? Because the ones I've seen on eBay isn't cheap and they haven't been tested. I paid £150 for my HP scope, which was probably... I've seen them go for cheaper these days on eBay, these scopes. But the guy was a really nice guy, and he also gave me another scope, a much older one, for free. So I didn't get a bad deal in the end. And it was in lovely condition. And I've been using my scope solidly now for about 2 years. Pretty much all the time. It's been really, really good. I love this scope so much that if it actually failed on me and I couldn't repair it or couldn't be bothered to repair it, I'd buy another one exactly the same. I love that. I love it so much. Brilliant piece of kit. Gian, how's those nerves on whether this is going to work? I'm still skeptical, even though it didn't present the issue just then on the small power supply. I'm still a little bit skeptical. I just don't know, because these issues can be a nightmare to trace, and I'll be very happy and relieved if I have actually managed to resolve the issue by discovering that it had the wrong type of FETs in there. Right, okay, so that's all the clamps back on. So let's go ahead and wire her up then to I'm just actually going to do one more power up on the small power supply. Anytime you do any work on the board, even just removing the clamps and putting them back on again, it's always a good idea to do one last final power up with your regulated supply, just to make sure that you nothing's moved or nothing's making a short circuit. Because if I go ahead and plug this into the Dell supplies now, and there's something that has moved that's now shorted, then the Dell server supplies will have absolutely no mercy, and they will blow up whatever it is on the board that's causing the problem. We'll do one last power up. See, I know this all takes time. This is like boring stuff, like test it again, do this, test it, clamp it back in, test it. But this is how I prevent stuff from getting damaged and blowing up, just from silly mistakes and whatnot. It's just, you might as well check it and check it again. It takes you an extra 10 minutes or whatever, but it's much better than it taking you an extra 4 hours having to then rebuild the amplifier from scratch again because it blew up because you missed something. Do you ever accidentally whack a component when you were first learning to do amp repairs, putting the clamps back in? No, I don't think I've accidentally whacked a component. What have I done? I've accidentally grazed a transformer by taking those clamps off with the Allen key. So when you pull the Allen key back, when the clamp gives way and it comes back, then the Allen key bangs into the transformer, and I've grazed the transformer doing that once early on. Don't think I've actually done anything bad with the hammer. Usually I use the hammer and a chisel, but these ones they have enough surface area here. I can just get away with using the hammer, and it's actually a little bit better. So let's do one last final power up then, just with the small power supply, just quick. There we go. Something doesn't seem quite right here. Hang on a second. That's interesting. It's doing something strange there. It's like it's kind of pulsing. It wasn't doing that just a moment ago. So why is that? What's not happy now? Something is not happy just now. What's changed? See, this is why I didn't want to power it up on the Dell supplies just then. It could be my supply here glitching around. So let's turn it down to 10.5 amps, 10.5 volts, sorry. Now it's doing something weird. So we still have a green light. It's not in protection. The drive wave has disappeared. Why is that then? What's it doing? Something funny going on. It's almost like maybe there's not enough current. I think it could be to do with this power wire, because this power wire just got stripped a little bit actually. So let me just try and improve the connection to the power wire. It could be that. Yeah, actually it could be that. I've got like one strand left on this power wire. It could be that. Let me just resolve that issue quickly. Hopefully that's the problem. It's almost like that. Yeah, when the amp fired up into operation, it almost seemed like the rail voltage, you see there, the drive waves, they started to get smaller and then the thing turned off. So yeah, it could have just been that power wire, hopefully. Ah, phew! Oh, no, wait. What's it doing? What the fuck? Let's take the fans off. Maybe there's a short circuit on one of the fans. No! What the fuck is it doing? All I did was take the clamps off, shift the board up a little bit and put the clamps back on. The fuck? Okay, looks like we're gonna have to take this out of the case again then, because that's all I did that was different. doesn't even go into protect. It's just the drive wave just disappears. My amps was jumping around, was it? Okay. It's almost like the power supply section couldn't work out what it's almost like the power supply section couldn't work out what pulse width modulation to be at, which was affecting the output drive wave. These come off much quicker than they go on, don't they? Ah, that's interesting. That's very interesting. I just had a spark to the heatsink, but the heatsink isn't connected back to the board yet, so something must be shorted to case, to heatsink ground, because the heatsink isn't connected back to the board again yet. I haven't put that wire back on yet. That's interesting. Okay, so I've just moved her slightly off of the here. I'm going to take a quick look down here inside the case, just in case anything is touching anywhere it shouldn't be. No. No, we're all looking good in there. Right, so I've moved off of the case now. So the case, I haven't actually put the ground wire back on at all yet. I wonder whether Q17 needs... Ah, hang on a minute. Hold on a minute. This appears to be missing a... Oh no, it's not. No, it's not. It's fine. Okay. Right. So we're off the heatsink a bit now. So I'm going to power it back up. And there should be nothing on the heatsink. The heatsink is not connected to the board at all. It's just a piece of metal floating outside of the amplifier. So if I take my multimeter, we shouldn't have any continuity whatsoever to the heatsink on any of these parts. There shouldn't be anything whatsoever. I wonder whether it was actually one of the speaker terminals was actually shorted to this little thing here, because I noticed one of the grub screws just fell out as I took the amplifier back out. Right, let's power the amplifier board back up just now whilst it's half out the case and see whether that issue has gone away. Dual, triple, quad inputs do massively help. Yes, with big amplifiers and current draw. Yeah, they do. They do help greatly. Are there much components you can upgrade in an amp to improve reliability and power? To improve power, not really. You can, if you really know what you're doing, you can make the amplifier more stable at a lower impedance, therefore get more power out of it at the lower impedance. Reliability, you can install better, higher spec FETs. Again, if you know what you're doing, if you can check that the drive circuit can drive them properly. But yeah, generally, not massively. Not a lot you can do. A few bits here and there, but nothing massively. Okay, let's go again then. Hopefully this stays on now. Really weird issue that I was just having. It wasn't displaying that problem before. Okay, it's back to being stable. So yeah, there was definitely something wrong with the case in the heatsink, but I don't really know or understand what. Alright, because there's nothing. I don't understand. It must have just been one of the grub screws on the speaker terminal then that was just shorting to the case. But the case wasn't touching anything else. That's what I don't get. Very strange. I'm very confused right now. Very confused. Okay, let's discharge the rail caps before I break anything. Right, so that works. So if we slide it back in to there, okay. Connect up the fans. So yeah, we're slid back in. I think, is that as far in as we can go? Yep. Okay, it's as far in as we can go. Alright. So now let's power up again. Now that we've slid her in a little bit. Okay, yeah, back to being stable. Alright. Okay, back to being stable. So again, discharge the rail caps. And let's put some of the clamps back on. Whoa! Did you see that spark? Lovely, lovely stuff. Nice capacitor discharge spark there. Love it. Ned Frost, long time, buddy. How's it going? Like, we're on the brink of solving this amplifier and it's just decided to throw another headache at me to do with the case, which is really, really strange. Yeah, I'm very well. Been absolutely ram-packed busy with this repair stuff. But yeah, it's been going really well. I've been kept busy. And I've had a lovely summer so far. It's had wicked weather here. And I'm going to Oklahoma in August. So that should be the highlight of my year, I imagine. I'm going to go visit DD headquarters, Digital Designs. Going to go visit their factory, see them build some woofers, go to Knowledge Fest with them. So, I've done half of these FETs. We should have absolutely no continuity to anything on the board here. Between the heatsink and anything on the board. Anywhere. Right, good, we don't. Okay, let's put the other ones on. I'm taking these clamps on and off far more than I expected to. I live in Oklahoma. Where they're out of. Huh? Right, so that's all the clamps back on now. So once the last time, let's check for continuity between anything on the board and anything. Aha! So something is connecting the board to ground, but where? It's connecting the board to the main ground. Where is it doing that though? Ah, it's through the fan wires. So one of these fan wires must be shorted to case ground? Somehow? It's not that one. It must be this one. Yeah, well, so this fan is shorted to case ground, so I'm going to have to sort that out afterwards, but that's something we can do at a later time. So let's remove the fan, and yes, we have no continuity to ground anymore. Right, cool, so let's go and power this up, and hopefully then this doesn't present the weird issue again. Why does my camera keep moving? Keeps going like this. Okay, good. Looking pretty stable. Great. Cool. So we're stable again. Okay, fantastic stuff. Oh, no. What the fuck? What? What? What's it doing? This is what the power supply is doing when it turns off like this. There we go, it's gone off again! What the fuck? Right, let's probe the case. Let's see if anything's on the case. We've got 14 volts on the case. That's not right, and we've got a 21 volt square wave on the case. Right, what the fuck? Okay. Let's remove, that looks like an output section square wave. So let's remove the clamps for the output section. Let's bring the FETs off of the case. And let's see if it still turns off like that. Only seems to happen after you put the last clamps on. Yeah, it did it for a while though. I think maybe it does it at different points. So I'm going to take the output section clamps off. I'm going to move the FETs away. Right, so we've moved the FETs away from the case now. There's nothing on the case anymore now. Please stay on. Please stay on. Okay, so it appears to be staying on, so it must be something to do with the output section. Now, this could be my fault. This is a bit confusing because the amplifier comes with insulation to the heatsink already. It already comes with that on behind the FETs, but it also had this this insulation tape. When I thought that was excessive, why does it need both? But it apparently, perhaps it does need both. Yeah, it's staying on indefinitely now, so it is definitely something to do with how the output FETs are clamped to the heatsink there. So let's put this original pads back on, and that should hopefully solve it. But that's really strange because it's already got the pad, so I don't understand why it would need another one. It's almost like the pad that's on there, the one at the back, isn't quite electrically resistive enough. Really, really strange. Come on, I just want to get to bench test this thing. Okay, so does that solve it? I'm going to leave it on here for a little while now, just to confirm. Seems good so far. Yeah, I think that was the case. So now, if I probe the heatsink, we went from having a 21 volt square wave to now having a 6 volt square wave. So, yeah, I think that probably was the case. There was probably some interference being picked up back through the FETs. So, okay, good. So that was my fault because I took the insulation off that I assumed it didn't need, and for some strange reason it needs double insulation on there, which I've never seen before. Right, okay. Not to worry then. Cool, right, now becomes the interesting part where we do a full bench test on the Dell server power supplies, and we see whether changing those FETs, which is the thing I did originally, just now this evening, solves the problem entirely or not. If it doesn't solve the problem, I don't really think I have much else to go on, unfortunately, Gian. So, if this doesn't solve the issue, then I'm a little bit lost for this one. What about the fan? Yeah, I can sort the fan's not an amplifier issue. The fan's just a stupid fan case issue. So once I fix the amplifier itself, I will go ahead and I'll take the fan out of the heatsink and I'll find out where it's shorted to and solve that problem. But that I can just leave the fan disconnected for now, while I resolve the issue with the Class D switch section. And once that's fixed, I can then put the case back together properly, fix the fan, and then give it back to Gian. Power wires in. RCA's connected. Looks like I've sat on my RCA connector. This is the first time I've ever done that with this wire. Let's reshape that into a circle again. Probably actually better for it being slightly off circle because it makes a better connection against the ground. There's more pressure against it. So that's that. Now we just need the remote wire over here. Remote cable, yes, done. Now are we isolated from the ground? I can't remember. How was I probing this before? Did I still have my oscilloscope ground thing connected or not? Because I can't float these power supplies like I can. How did I do this last time? When I was probing the output section, with it before was, did I have my thing grounded to the middle of the board? I don't think I did. I don't want to connect the two grounds if they're not supposed to be connected in the first place. So I think I'll leave that off just for now, and we'll have a look at the output wave only. So I'm going to drop one ohm. No, what I'm going to probably drop. What should I drop? 1 ohm or 2 ohm? I should probably drop a 1 ohm just to confirm this is definitely fixed correctly. So if I drop a 1 ohm into this now, let's get the grub screw back that fell out. Do manufacturers still make those surfboard amps? Not really, no. Not really. I believe you had a separate ground for the oscilloscope because the grounds of the power supply weren't connected. The problem is with the Dell server power supplies, I can't isolate it from the main ground, which is what my scope is connected to ground with. So I've got a feeling that I didn't connect up my additional ground wire to the output section for the scope when I had the Dell server plugged in. So I'm just putting the 1 ohm dummy loads connected now. This will put large stress on the amplifier, which is what we want. We want this amplifier to be under a lot of stress just now. I'm also going to do something else when I hook this up. I'm going to swap out my foot pedal, which turns on the remote from my regulated power supply usually. I'm going to swap that, and I'm actually going to put that on the main power for my Dell server power supplies. And the reason for that is so that if anything does go wrong with the amplifier, I can very quickly release my foot from the pedal and cut off all power to this amplifier in case of an output section failure, so that we hopefully save the power supply if there's any problem there. Stick my multimeter probes in here just to read the voltage going into the amplifier from the 4 gauge. This amp does only have 4 gauge inputs, guys. Only 4 gauge inputs on this 2.5K. And lastly, I need to, yes, put my foot pedal on here. Proving harder than expected. Okay, almost there. Oscilloscope probe in the outputs, and then we're good. This isn't a huge amplifier. This isn't massive. No, this isn't 5K. This is a 2.5K, Tony. 5K is the peak figure. So this is only a 2.5K amplifier, really. Right, moment of truth. What's it gonna do? It seems that my camera is stuck. Ah, there we go. Gian, I'm really tired and pretty sick. No worries, man. But try and stay awake just for this test, because this is going to test whether we fix it or not. Okay, yep. So the pedal is working for the power. Whew. Slightly nerve-wracking. Let's get our gain here. Okay, let's go. Seems that my pedal doesn't work now. Anticlimactic. Okay, here goes. Uh-oh. Nope, it still does the same shit. Ah, fuck. I really thought we had it, guys. Nope, it's still doing the same thing. Fuck! Okay. Well, I don't know then. Bugger. No, fucking no idea. I really was riding on that working. Fuck's sake. Sorry, Gian. I don't think there's much else I can do with this. Honestly, don't know what else would cause that to happen. I mean, I could try changing all the chips on the driver board over here. I could try just blindly changing all the chips, but I don't think it's on the driver board that the issue is. I'm going to probe some more stuff. Yeah, the wave proper drops out there. I'm not entirely sure what this big ass noise thing is here. That must be a feedback. This is on the HEF 4060 chip. And this drops out with the wave. I wonder whether replacing the HEF 4060 will work. I have no idea. I have no idea. That's a shame. Sam, did anything get hot when the amp was under load? Like generally, the normal sort of stuff gets hot really, I mean, like warm. The 4060 chip gets a bit warm. A couple of the comparators get a bit warm. Well, no, these couple of these small amplifiers on the driver board get a bit warm. You got the voltage regulators getting warm. The high side FETs get hot when the amplifier is put under load and the issue presents itself. So the high side FETs get hot. So it's obviously like a high side drive initial issue. I've traced the noise back. The problem with the noise is that it's in the feedback loop. So whichever component is creating the noise will also occur before it and after it, because it's part of the feedback loop. So it's not easy to isolate where the issue is coming from just purely based on what component has that noise on it. I mean, the thing is, the previous technician that worked on this changed so many things that it could be that something that he changed for a different part it does not happy with. But from what Gian has told me, this technician has repaired many of these amplifiers, probably with all these same parts, and they all usually work fine with what he does. And the fact that this one doesn't is obviously a problem. Could be something as simple as a tiny ceramic capacitor on the driver board, or a tiny diode, a Zener diode or something on the driver board. But I don't really have a way of confirming which of those it is. Because I don't have another working. See, that's the thing. If I had another working one of these here, I could compare the waves and the voltages on all the different parts of the driver board, which is what I've done before with the Taramps. So I had a Taramps 10K and it had a drive issue different to this, but it had a really annoying drive issue, and it turned out to be a single tiny SMD ceramic cap that was the problem. But I was able to find that because I had a working one and I could compare all the waves between them, whereas I can't do that here. So I'm kind of lost in the dark now with what could be causing that. I spoke to Gordon at the Amp Doctor and he suggested that the drive wasn't strong enough, and if the high side drive wasn't strong enough then it would present this issue when the FET is put under load. But I have gone through and checked the high side drive voltages, and they're all high enough, way high enough to turn these FETs on and off. There's not a problem there with the drive amplitude. That's not the issue. I don't understand what else would cause that to happen only when the amp's put under load. It doesn't make any sense. Need H1 Nick, maybe. But what if this guy's soldering was good? I'm just going to go ahead, I'm going to discharge the caps, I'm going to see whether there's any loose legs on any of these drivers here. Just in case something isn't soldered properly. The soldering all looks top notch, to be honest. It looks really good. Like, it looks like the guy knows his stuff, knows what he's doing. The repair looks like pretty solid. So I would love to have a replacement driver board for this, so I could just swap the driver boards out and see whether it was that. But unfortunately, this is a driver board unique to STEG only, I believe. So I don't think I'll be able to get another one of these anytime soon. That would be the ideal thing, just to drop a new driver board in and see whether that resolves it. And that's what I usually do on most other amplifiers that have generic circuits, generic driver boards. But unfortunately, I wonder if I can contact STEG. I wonder if they can supply a new driver board. Obviously that will cost some money, and if the new driver board doesn't resolve it, then we will have wasted that money on the STEG driver board. But that's pretty much the only thing that I can suggest to do next. The only thing that I can think to do next is to try a new driver board. If a new driver board doesn't solve it, then there's only very limited components on the board left for me to check. So that would take out a whole chunk of it. If fitting a new driver board and the issue didn't go away, then that means, okay, fine, that's annoying, but let's go through and let's change all the other shit on here again anyway, and see if that resolves it. But for today and for the time being, sadly I'm going to have to put this one to one side while I think about what to do. Ever tried asking Reddit for specific info? I once asked if anyone could measure or take pics of the straps on a Ferrari for me once, and 2 people replied with pics within a day. No, I haven't thought about that. I didn't really expect Reddit to be a haven for car amplifier repair techs, but I suppose it might be. The schematic won't really help, John. I understand this. I understand how this circuit is working. I can tell you exactly where all the traces go and how they all connect with each other. Having a schematic won't tell me why we are missing the top half of the audio wave when driven into a load. That's not going to help me out. The noise, John, doesn't have a source. It's not like a Class AB amplifier where the noise will have a source. It will be present at one point and then not present before the issue. This is a Class D feedback loop, so if there is one component that is causing the wave to drop out, then the wave will be dropped out everywhere on the feedback loop. So at the drive IC, at the generation IC, at the buffer ICs, at the gates, everywhere. That issue with the drive dropping out will be absolutely everywhere that there is Class D drive. So I can't trace it back because I'll just go in circles. There's no place that it starts that you can see on a scope or anything like that. If the amplifier did this problem without a load, then I possibly could trace the issue back by taking the FETs out of the board so that there's no feedback loop and driving an audio signal to give me the square waves for the Class D and then trace it back that way. But that won't help me here because the amplifier needs to be loaded on a speaker for it to give me the problem. So I can't do that. What the fuck? Is the noise analog? If so, what frequency? No, it's not a noise, John. It's the issue is not a noise. The issue is a Class D. The Class D switching frequency drops out. It drops, and therefore it causes half of the FETs to drive the others. It's not a frequency. The top half of the audio wave just disappears, and therefore the low side is driving the high side, I think, and the high side gets hot, overheats. So if it doesn't have the problem without a load, it wouldn't work comparing the waves or probing it, probing and comparing that to probing load. No, that won't work either, because I can see the waves. I can see the issue with the waves when it's loaded, but it's in the feedback loop, so I can't isolate it to one area. It could literally be anywhere. I mean, I suppose I could go around and compare all the DC voltages on all the small SMD capacitors on the driver board when it's loaded versus not loaded, and see if there's any weird spikes or any voltage that disappears when it shouldn't do. I could try something like that, but that'll, you know, that's something for another day. It's getting pretty late here. That's going to take me hours to do that. I would like to try and first of all ask STEG if they can send me a replacement driver board. If they can, then I'll try and fit that first. If that doesn't solve the issue, then I'll do what Gian suggests. If they can't send me one, then I will probably do what Gian suggests anyway. Is that a smoked vape tank on some weird rig? Yeah, this. So I've got my adjustable power supply here that I power the amps up on, and I also vape off it as well, so I can set my current limit. So this smoke tank likes a maximum current of 12.5 amps, and so obviously I can just hit that. It doesn't matter what the voltage is set to. The voltage can be set to high or low, because once the amp kicks in, then it just turns the voltage down to, as you can see, 3 volts there. So you've got 3.9 volts, 12.5 amps. And it works really well. The vape tank can't explode. There's no explosive parts in a vape tank. The only vapes that explode are ones with the batteries, where the batteries explode. The actual tank and the coil can't explode. It's a coil. It's going to burn out. It's going to go. It could catch fire. It's never going to explode. The coil's getting pretty burny. Actually, I need to replace the coil in this. Ah, right. I think I'm going to call it a night. Getting pretty late now. 1:30 in the morning. Like, for this to catch fire, I would have to be dumping probably 50 amps into it for about 5 minutes solid, so that's never going to happen. Yeah, like, similarly, so Tony's very right, actually. This is actually going to bug me. This is going to bug me. Like, I'm going to go to bed tonight and I'm just going to be laying in bed just like fucking thinking of this drive circuit and just thinking, oh, what can be causing, like, this is all I think about. If I've got a problem like this that I can't solve, it drives me nuts. Okay, I'm going to go away and have a think about this and speak to some people, contact STEG, see if they can help. And I think I'll come at this with some fresh ideas at some other point. So cheers for watching the stream, guys, and cheers for watching my massive failure this evening. I'll catch you in the next stream. See you later.